Let me test this. All right, hang on a second. Um, Hello? Okay. All right, I just had to make sure that I have working speakers and the microphone there. All right. This is going to be the second asynchronous lecture. So this is going, we had one on the other day, on the radical adding and subtracting, multiplying the radicals. And we also looked at the rationalizing radicals. So this is a continuation of that. So today we're going to talk about the solving radical equations, and then we're also going to talk about the imaginary number because later on we're going to have to talk about the imaginary number, and that becomes part of the solution when we solve the quadratic equations. I will probably going to talk to you guys about what's happening in next couple of weeks, but I know that we are scheduled for exam 3 for October 26th, but I'm going to postpone that until following Monday, which is November 2nd. So we'll talk about that when we come to class on Monday, October 26th. Okay. But for this video, we are going to look at the hang on a second, let me share my screen here. We want to look at the radical equation. So there are a few different types of radical equations. So we want to look at each of those type. So whenever we have the radical equations, we are looking at the radical on one side, and maybe have another constant on the other side. But now the radical has equal sign, okay, and equal to something. So that means that we're going to have to eliminate the radicals, but there's few ways that we need to do that. Okay, so let's just talk about the few different types of radical equations. So I'm just going to write into it. So let's say we have equation something like square root 2x minus 3 and minus 5 equal to 0. So whenever you have one radicals, you need to isolate the radical and then move everything to the other side. Okay, so we have here the radical and the constant. So we're going to add 5 on both sides to isolate the radical. Okay, so that means I have a square root 2x minus 3 equals to 5. So that means we're going to have to get rid of this square, right? Remember that, if I have, let's say, x to the square root of x, and that's just going to be x to the 1/2. But we don't want the rational exponent there. So if that's the case, we can apply the power rule of, if I have x to the 1/2, then if I multiply the thing by 2, then you get x. And that's what we're going to do on whenever you see the radical sign there. So you can think of this as a 2x minus 3 to the 1/2 power. And in order to eliminate the rational exponents, you're going to have to multiply by its reciprocal. In this case, 2, right? But because of this equation, whatever do you on one side, you're going to do the same thing on the other side. So what I mean by that is this. So I have like, 2x minus 3 to the 1/2. So what I am doing here is that I am going to multiply the exponent by 2, and I have to do the same thing on the other side. Now by the rules of exponent of the power rule, that just becomes 1. So you get 2x minus 3, and you get 25. Okay, so that's how you're going to get rid of the rational exponents. You're going to have to remember that if you do, raise everything to the square, then you do the same thing on the right-hand side. If you don't, you are changing the problem. It's not going to work. So here now we're going to add 3 on both sides. So then we have what? 2x equals to 28. And then we're going to divide by 2. So x is going to be equal to 14. That's not bad, right? So as long as you have a one radical and some constant, you're going to have to remember that you need to isolate the radical on one side, okay? Let's try another one. Okay, so let's say we have something like this. You got square root 3x plus 10, similar to what we just did here, plus 2 equals to 4. Okay, so now, again, we're going to have to isolate the radical. So I'm going to subtract 2 from both sides. Okay, so that gives us the left-hand side, square root 3x plus 10 equals to 2, right? Now, again, we're going to have to, you can rewrite this as a 3x plus 10 to the 1/2. And we are going to raise everything to the square. And we're going to do the same thing on the right-hand side. So there will be a 2 to the square. So on the left-hand side, we're going to have what? 3x plus 10. And you're going to get 4. Now we're going to subtract my 10 on both sides. So that means I got 3x equals to minus 6. And divided by 3. And x equals to minus 2. And I have some students saying, oh, wait a minute, x equals minus 2. You cannot plug in minus 2 to the radical, under the radical. In this case, square root. But that's not true though, because if you plug in minus 2 under the radical, you get minus 6 plus 10. You're still going to get 10. A positive, right? Minus 6 plus 10, you get 4. You're not getting any negative sign there. So it is a good idea that you always want to plug the value that you found back into the radical. Make sure that it does not violate any law that we know of. Then again, when we go to the imaginary number, it doesn't make any difference whether the x is positive or negative, because we can also express the square root of a negative radican into imaginary number. Okay, and make sure that you guys check. Okay, like this. Okay, 3 times minus 2 plus 10 plus 2 is this equal to 4? Obviously, you got square root of 4, right? So 2 plus 2, you get 4. So that one checks out okay. Now let's just look at the one right now. We haven't talked about the imaginary numbers. So for now, we are going to assume that you cannot put anything inside the square root that is going to be end up with a minus. So let's say we have something like this. You got square root 5x minus 1 plus 7 equals to 5. So I'm going to isolate the square root. So I'm going to subtract 7 on both sides. So that means I have a square root of 5x minus 1 equals to minus 2. Now, this is the problem here. You cannot have this square root cannot be equal to minus 2, right? It has to be always positive because you cannot have a negative under the square root. So every time you have the square root and you got some equal to some negative quantity, that means that it's not working. In other words, that your square root has to be equal to positive quantity. Otherwise, it doesn't make any sense. So in this case, we would say no solution. Okay. Or you can just say, the 0 with the, the line cross it, or you can say the empty set. All right. All right, so what about the different types of radical? You might have some radicals that, on the left-hand side, you have radical, but on the right-hand side, it's not, you don't have radical, but your variable, you still have it. For example, you got square root of x plus 5 and equals to x minus 1. So what do we do? Well, you're just going to have to get rid of this square root over here. So we're going to square both sides. Okay. And you're going to do the same thing on the right-hand side, which is a square. And if you look at the on the left-hand side, that just becomes x plus 5, right? Because if I rewrite the x plus 5 to the 1/2 power and you raise it to the second power, you're just going to get x plus 5 on the left-hand side. Now on the right-hand side, you're going to have to multiply this. Let's just use the table here. So you got x minus 1, then you got x minus 1. So you have what? X squared minus x plus 1, right? So you end up with what? X squared minus 2x plus 1. Okay, so you have x squared minus 2x plus 1. Now, since we have a quadratic equation, everything has to come over to one side and the other side has to be equal to 0. So we're going to subtract x here and subtract 5 here. We do the same thing on the other side. So you got 0 is going to be equal to x squared minus 3x minus 4. Now we need to solve this one. So we're going to have to factor this. You can have, let's factor this again. I can have x and x over here. Then I can have what? Minus 4 and plus 1. Because, vertically you multiply, you get minus 4. And if you cross multiply and add, okay, you get x. So minus 4x plus x, you get negative 3x. So the factor form of this equation is going to be x minus 4 times x plus 1. So that means we have x minus 4 equal to 0 and x plus 1 equal to 0. So your answer is going to be x equals to 4 and x equals to minus 1. Now, the one thing that we have to be careful is that, like what we just did to the previous problem, you're always going to have to check your answer, okay? Because you got answer, it does not mean that those are the solution to the given problem. So you need to check, these solution there. So if I use the x equals to 4 and check it out, plug it in there. So you got square root of 4 plus 5. Is this equal to 4 minus 1? So that's going to be square root of 9, right? So that's 3 is equal to 3. So that checks out okay. What if I have a minus 1? So let's just do that. So you got square root minus 1 plus 5. Is this going to be equal to minus 1 minus 2? Minus 1 plus 5 is going to be 4. And square root of 4, you get 2. But that's not equal to minus 2. So therefore, the minus 1, okay, is not a solution. Okay, so be careful on the test though. I know I have a lot of students, oh yeah, I got these two solutions and they are the answer. Not really, because until you, go back to the original equation and try those, values, if they don't make sense, then it's not part of the solutions. Okay, so be careful. Once you solve for x, and make sure you go back and try x. Okay, so you're not going to have any problem there. Okay. There's another type of problem that people get really confused. Is the when you have the radical equation, radical on both sides. Okay, so let me just do that. So let's say we have something like, square root of, 3x plus 6 minus square root of x plus 6 equals to 2. If you have two radicals like this, you're going to have to put one on left-hand side and the other one on the right-hand side. Okay? You cannot square the both sides as it is. You're going to have to do it as a single radical. Okay, so if you have two radicals, it doesn't matter whether you have one radical on the left-hand side and one radical on the right-hand side, or if you have both of them like this, it doesn't matter. You're going to have to split this into one on the left and one on the right. Then you're going to square the both sides at the same time. Okay. I have a lot of students who, what they try to do is that they're just going to be, square this one over here, then square on the right-hand side. That's not way to do this one. Okay, so you need to have to make sure that you have to move the one radical to the other side. Okay, so that you have a one radical on the left and the one radical on the right. Now you can still have, like this problem, you can have radical plus something. It's not going to be a problem, but the one thing that you cannot do is you just square the both sides with the two radical on one side and no radical on the other side. You cannot do that. Okay, so split radicals on both sides here. So I'm going to do is I'm going to move one of the radicals to the right hand side. So I'm going to do that. So I'm adding this quantity here. So you will get, square root x plus 6 plus 2. Now square the both sides. Okay. So, just like the previous problem that we did, this just becomes a 3x plus 6. But the right-hand side is not x plus 6 plus 2. You cannot do that because the plus is in between. So what you need to do here is that you're going to have to multiply this twice. So let me just show you. So you got square root x plus 6 and 2 And you got square root x plus 6 and 2. Okay, so multiply cross, you got square root of x plus 6 times the square root of x plus 6. That's just going to be x plus 6. Okay, so you got x plus 6 to the 1/2 power times the square root of x plus 6 to 1/2 power. So 1/2 plus 1/2, you get 1. X plus 6 to 1/2, 1 power is going to be 1, right? Now, next one is going to be 2 times square root x plus 6 here. Same thing over here. So 2 square root x plus 6. And that one's going to be 4. All right, let's rewrite this. I have x plus 6 plus 2 square root x plus 6 plus 2 square root x plus 6 plus 4. I'm going to do some housekeeping here. So on the left-hand side, I still have a 3x plus 6. We can add 6 and 4 right here, right? So that means I have x plus, okay, 10, plus you got 2 of this quantity, 2 of that quantity. So I've got what? 4 square root and x plus 6. Okay, so I'm going to isolate the radical on the right-hand side. So I'm going to subtract x and subtract 10. And I'm going to do the same thing on the left-hand side. So I have what? 2x minus 4 is equal to 4 square root of x plus 6. Okay. Now on the left-hand side, the common factor is going to be 2. So I'm just taking out the 2. X minus 2 equals to 4 square root x plus 6. And I am going to divide both sides with the 2. Okay. So on the left-hand side, I still have x minus 2. On the right-hand side, now I have what? 2 square root x plus 6. That's kind of nice, right? So now we got everything that we need to do before we square the both sides. So let's just do that. So we are going to square both sides here. So x minus 2 square. And I have a 2 square root x plus 6 to the square. If you use the table to square this one, I get x squared minus 4x plus 4. Then this one I get what? 4 times x plus 6. Okay. Now we're going to expand this a little bit. Okay, so we have what? X squared minus 4x plus 4 equals to 4x plus 24. Now, because we have a quadratic equation on the left, we're going to have to bring everything over to the other side. So I got minus 4x minus 24 minus 4x and minus 24. So on the left-hand side, I have what? X squared minus 8x minus 20. Okay. And on the right-hand side, we are going to equal to 0. Now, we're going to have to factor this. So we have x squared minus 8x minus 20. So here I can have x and x. Over here, we can have a 10 and 2. And the 10 has to be minus, because minus 10 times 2, you get minus 20. If you cross multiply, you get minus 10x. And cross multiply this way, you get 2x. So 2x minus 10x, you get minus 8x. So that's good combination. So we're going to write it as a factor form. And x minus 10 times x plus 2 equals to 0. All right, so that means we have what? X minus 10 equal to 0. So x equals to 10. And the x plus 2 equal to 0, so x equals to negative 2. Again, we're going to have to check these, the value that we found, claim to be the solutions. Okay, so let's try the both and see if, and both of them are the solutions to the given equation there. So let's try this guy here. X equals to 10. Let's plug it into the original equation. So you got 3 times 10 plus 6 minus square root of 10 plus 6. Is this going to be equal to 2? So 3 times 10, you get 30. 30 plus 6, you get 36. Square root of 36 is going to be 6. Minus 16. And square root of 16 is going to be 4. So that means the 2 is equal to 2. So x equals to 10 checks out okay. Let's try minus 2. So you got square root 3 times minus 2 plus 6 minus minus 2 plus 6. Is this going to be equal to 2? Well, that's a 0, right? 3 times minus 2, you get 0. And the minus 2 plus 6, you get square root of 4, which is the 2. But minus 2 is not equal to 2, right? So that's false. So therefore, this is not the solution. X equals to 10 is the only solution for this problem there. Okay. So I just want you to make sure that you guys understand how to solve the radical equations. Now there's another one that we might want to look at. It's called, if you have, the equation is going to be something like, instead of a radical, you're going to end up with the, some sort of a rational exponents, and, how you're going to do that. So, sometimes you do see something like this. So I'm just going to show you. Let's say you have a 5x minus 1. So instead of, square root, we're going to use the rational exponent. Plus 3 equals to 10. So if you don't like the rational exponent in this case, you can just rewrite it as radical like this. You get 5x minus 1 plus 3 equals to 10. Then you just solve for the for the x inside the radical there, if that's what you want. Okay. So it doesn't make any difference as long as you understand that square root is the 1/2 power, and the cube root is going to be 1/3 power, and that's all that matters. Okay, so whether you would do this way or using the radical, it's not going to make any difference. So just regular way, subtract 3 from both sides. So then you got what? 5x minus 1 equals to 7. Now we're going to square the both sides. Okay. So that means we have what? 5x minus 1 equals to 49. And we're going to add 1. So that means we have a 5x equals to 50. So that means x is going to be equal to 10. Okay. And if you plug in 10, you should get the right answer there. All right, so that's how we're going to solve the radical equation. Now, I've been saying that, you cannot have any, negative numbers on the square root. So we're going to talk about something like called the imaginary number, or called the complex number system. So let me just look at the complex number system. What we are trying to do here is the what happens if you have negative inside the square root. I mean, how are you going to take care of that? So what we're saying here in this case is this: you got x squared equals to -1. Okay, well, what happens to that? All right. So we are going to define something called the imaginary number. Okay, I forgot to -1 here. We have something called the imaginary number. Okay. And we use the I as imaginary number. And the imaginary number, if you look at this, okay, and the way we're going to define, okay, is from here. So what we're saying here is that, I simply is equal to square root of -1. Okay. So whenever you have the number or the variables, whatever that you have, and you're going to end up with the some sort of a negative inside the square root, you need to rewrite it into what we call the imaginary number. Okay. So interesting fact here is that if the I equals to -1, then I square. If you square both sides, okay, you get -1. Okay, I hope this is not very difficult, because from here, if you square left-hand side, and they're -1 to the 1/2, right? That's the square root is. And if you square them, and that's what you're going to get. Now then, if I look at the I cube is what? Oops. I cube is going to be what? I squared times I. But I squared is a -1. And then you multiply by I, so you're going to get with a -I. Well, what about I to the 4th? Well, we already know what the I cube is, right? You got -I, right? So this is the same as the I cube times I. But IQ is going to be a -I. Okay, that's what it says right above there. Then you're going to multiply by I. But you're going to end up with a -I squared. But we know that I squared is -1. So you got -1, we get +1. So this kind of cycles. And if I go to I to the 5, then you're going to end up with a -1. I mean the I. And so it's like a set of 4. It kind of rotates. In other words, that they cycle. So that's what the imaginary number is. It's just going to be a -1, square root of a -1. So whenever you have the square root of negative numbers, you're going to have to rewrite it in the imaginary number. If you don't, you're going to be big trouble. Okay. So let's just look at the few examples. If I have a square root of a -3, now remember that this is going to be same as the -1 times 3. And we can separate this, because of the property that we know from the radical. But, -1, square root of a -1 is going to be I. So this comes out to be I square root of 3. There's some other cases that we're going to have to look at. For example, like if I have square root of a -16, this is not going to be a -4. If you multiply -4 times -4, you're going to end up with a +16, not -16. So that doesn't make any sense. Don't say that this is a -4 because it doesn't make any sense, right? So if you want to rewrite this, you're going to have to rewrite it as a definition there. So you got -1 times 16. Again, separate that into two radical. -1 times the square root of 16. But you know that square root of -1 is I. Square root of 16, but square root of 16 is 4. So this one's going to be 4i. Sometimes you do not get, nice, clean way out of the radicals. So you're going to have to take care of that also. So if I have a square root of a -18, again, we're going to write it as the -1 times 18. Again, separate this. You got square root of a -1 times the square root of 18. So the square root of -1 becomes I. But 18 is going to be 9 times 2. I mean, otherwise 3 times 3 times 2, right? So then this becomes a 3 square root of 2. So you can say this is a 3i square root of 2. We can also do the operations on imaginary numbers, okay? Now, before you do anything else, you're going to have to make sure that you convert the negative square root into, the positive using the I in this case, okay? When we look at the imaginary numbers, sometimes you're going to have to combine with the integers or the whole numbers, whatever. So we have something called complex numbers. Complex numbers are the entire, in other words, the largest set of the number system. Okay, so complex number system is going to be something like, a plus b I. So this a part over here is just going to be the what we call the rational numbers. In other words, that a portion, the a part over here is going to be always just a number, no imaginary number. And this part here, we call this imaginary part. And we call this the real part. So the complex numbers always consist of real and imaginary part. When you combine them, we get complex numbers. So we're not used to looking at the imaginary part when, in everyday life. But because, we just don't write it. It's supposed to be, like if you have a 3, then it's supposed to be 3 plus 0i. But 0i is going to be 0 anyway, so we don't write them. But technically you have two parts in any numbers that you see, whether it's integers, rational numbers, or anything like that. Okay. We can add, you can add the complex numbers. So let's just look at that one here. So add, what happened? Add complex numbers or subtract. Okay. You're gonna have to, when you add and subtract, you add real to real and, imaginary to the imaginary. Okay. So for example, if I have like, 4 minus 3i plus minus 2 plus 5i, if I want to add these two, then you can only add real to real, okay, and imaginary to imaginary. So you got 4 minus 2, which is just the 2, right? And minus 3i plus 5i, you get positive 2i. Okay. So, be sure that you don't, mix the real number with the complex number when you add and subtract. Now, when you multiply, multiplying is a little bit different. So multiplying, we don't care. But multiplying the complex numbers, So multiplying complex numbers, you can just multiply to real to complex, whatever you have. It's not going to make any difference. So for example, if I have 4i times 3 minus 6i, so, you're going to have to use a distribution here. So that and that. So you will get what? 3 times 4i, you get 12i. And minus 6i times 4i, you get minus 24i squared. But we already found out that I squared is going to be negative 1, isn't it? So you got 24 times negative 1. You get 12i plus 24. It is the common practice that you always write the real part first, then the imaginary. So this should be 24 plus 12i. Okay. All right. Sometimes, just like when we multiply the polynomials, sometimes you're going to have complex numbers. You got two terms on both sides here, like minus 2 plus 4i, and we're going to multiply this by, let's say, 3 minus I. So if I have, like a box just like the polynomial, I have a minus 2 plus 4i, then you got 3 and minus I. You can also multiply them, just like you have done for the polynomial. So you got negative 6, 12i, minus 2 times minus I, you get 2i. And 4 times minus I, you got minus 4i squared. Let me rewrite that. So you got minus 6 plus 12i plus 2i minus 4i squared. So we can combine the I term over here. So you got minus 6 plus 14i. But this one, I squared, is going to be negative 1. So you got minus 4 times negative 1. So I have a what? Minus 6 plus 14i minus 4 times minus 1, we get positive 4. And if we combine the minus 6 and 4, we get minus 2. Then we get 14i. Okay, so that should be our answer there. Now, one thing that I want to mention is that, if you have, a negative square root, you must convert that into the imaginary number before you do any type of operations. Okay, so you cannot, use the, negative square root. You must convert that into imaginary numbers. For example, if I ask you to multiply these two, for example, I have 2 plus square root negative 16 and times 1 minus square root of minus 9. You cannot multiply as it is. Okay, you need to convert these two into imaginary numbers. Okay. So whenever, if I ask you to multiply negative square root, change it to imaginary number. Okay, so let's just do that. So this will be 2 plus square root negative 1 times 16. 1 minus square root negative 1 times 9. So we have 2 plus square root of negative 1 times the square root of 16 times 1 minus square root of negative 1 times the square root of 9. Okay. So 2 plus I, now square root of 16 is 4. 1 minus I, square root of 9 is 3. So what we have now is 2 plus 4i times 1 minus 3i. Now you're going to have to put them into the table and multiply them, just like what we did above. So you got 2 and the 4i and the 1 minus 3i. So you got 2, 4i minus 6i and minus 12i squared. Let's rewrite this and see if we can simplify a little bit here. So I have a 2 plus 4i minus 3i minus 12i squared. So if I combine these two, we get what? 2 plus I. Now remember, minus 12i squared is going to be negative 1. So you got 2 plus I minus 12 times minus 1, we get positive 12. And now if we can combine the constant terms, so we get what? 14. So we got 14 plus I. Okay. Unless I made a mistake here somewhere. Hang on. Did I write this one correctly? We have what? 2. Oh, wait a minute. We got 2 minus 6i. Okay. Oh, I wrote it wrong here. Okay, I made a mistake here. So that's supposed to be 4i minus 6i. Yeah, I wrote it wrong. Okay, sorry about that. So minus 6i here. So that means 4i plus minus 6i, you get minus 2i. Hang on. Just delete everything and redo the whole thing. Okay. All right, so we have what? 2 minus 2i plus 12. And combine these two, we get 14 minus 2i. That should be our answer there. All right, so now then what about dividing? Yeah, so let's just talk about dividing here. Sometimes we want to and when we rationalize a radical, couple of was that last night or the other day we talked about rationalizing denominator of the radicals, right? We can do the exactly same thing. In other words, that we want to clear the denominator from having imaginary number. So for example, if I have a 3 plus I, this is exactly same way that we did for the radicals. So we don't want the I at the bottom here. So in order, if you want to get rid of it, then, just like the radicals, we're going to have to multiply this by its conjugate. So we call this complex conjugate. Okay? I have a 5, exactly same thing, but opposite sign, top to bottom. Okay, so we call this complex conjugate. Okay, then you're just gonna have to multiply them. Okay, so let's just do the bottom one first. Again, I'm going to use the box over here. So I have a 5, 3i, then 5 minus 3i. So that will be a 25, 15i minus 15i minus 9i squared. So the bottom one over here, I have a 25 plus 15i minus 15i minus 9i squared. Now let's do the top. Okay. So I got minus 3 and I, then I have a 5 minus 3i. So I have a minus 15, 5i, minus 3 and minus 3i, you get positive 9i. Then I have a minus 3i squared. So let's write that on the top. Minus 15 plus 5i plus 9i minus 3i squared. So we're going to do some housekeeping here. So 5i, you got plus 9i. So that will be a 14i. Now the I squared is going to be your negative 1. So negative 1 times negative 3, you get positive 3. So I have a minus 15 plus 14i and plus 3. And same thing down here, but the difference here is that middle term drops off. So on the bottom here, you got 25, and I squared is going to be negative 1 again. So negative 1 times negative 9, you get positive 9. So on the top, combine the minus 15 and 3, you get negative 12 plus 14i. And bottom is going to be 34. Okay. Is it necessary that you're going to have to rewrite this as a 2 terms? Not really. I mean, if you can, simplify to the smaller term, then you are welcome to do that. So, let's see if we can do that. I have a minus 12 over 34 plus the 14I over 34. So just like the regular, the complex numbers, we got real part on the left and the imaginary part on the right. So if you divide the top to bottom by 2, you get negative 6 over 17 here. And same thing, if you divide top to bottom by the 2 on the second one, you get 7I over 17. Okay, so that should be the answer there. There is the one area that I want to show you. Maybe we don't have it. Oh yeah. This is a good practice of understanding the imaginary numbers. So I just want to show you something here. Let's say we have simplify. Okay, let's say I have I to the 1/10 power. Okay, so what would this be? Now remember that if you go back to the I is square root of -1, I square equals to -1, I cube is going to be negative I, and I to the 4th is going to be equal to 1. So what we really want to do here is that if we can somehow put them into the 4, base I to the 4, then we can just say that that's going to be equal to 1. And then we can kind of deal with the rest of them. So if you look at the I sub 110, I can rewrite this as I to the 100 times I to the 10, right? But if you look at this one over here, okay, I to the 100, okay, you can rewrite that as the, I'm just talking about this guy here. You can rewrite it as I to the 4th to the 25. All right? So you know that I to the 4th is equal to 1. So the entire this thing becomes 1 to the 25 times I to the 10. Now remember that, when we broke this in from I 110 to 110, we are using the laws of exponent. That's going to be a product rule here. And when I rewrote the I to the 100 to the 4 and 25, we apply the laws of exponent of power rule. Okay. So I mean, we have a 1 to the 25th power. That's just going to be 1. And 1 times I to the 10. So now how can we, rewrite I to the 10 so that we can have I to the 4th power? Well, we can do something like this, right? You know that the I to the 10, this is going to be same as what? I square times I square times what? I to the another. I'm trying to come up with the, okay. So 2, 4, 6, 8, and the 10, right? So in this case, if you look at the, 2 at a time, right? So now you have I to the 4th, I to the 4th, and I square. But we already know that I to the fourth is going to be equal to 1. So we got 1 times 1 times I squared. But we also know that I squared is going to be negative 1. So the entire thing is going to be just negative 1. So, using the definition that we came up with earlier, I equals to, square root of negative 1, I squared is negative 1, I cubed is negative I, and I to the fourth is 1. We can actually simplify some of the very, very big exponents using that property there. Okay. All right. So we covered the today, radical equations and the imaginary numbers. We'll come back on the which may call the 26th. We're gonna come back on 26th, October 26th. The one video that I did before today, and this one is gonna be the one that you guys have to watch. Okay. So let's make sure that you don't skip anything. Okay, make sure that you guys watch this video so you understand what's going on here. Okay. All right, I'm going to stop sharing, and then I'll see you guys on the Monday when we come back. In a couple of weeks. No, not next week, but following week. Okay. Thanks. Okay. Bye bye.